Alright, so here we have another problem where I didn't, look at the answer or anything. I just went on Google, copy and pasted in here, and I just, I'm looking at it right now. So I'm going to solve this, without pretty much prepping for it because I want you to see pretty much, my thinking process. As I solve a problem, what are my thoughts? Because that's an important tool to see. Because a lot of times I think students look at it and say, well, when they see the teacher do it, it's perfect every single time. And I want you to see that it's not the case. I mean, I struggled throughout all of mathematics, but keep in mind, as you struggle, you're growing. You're growing your mind. All right, so embrace that struggle because that's okay. All right. Remember, you gotta keep in mind the growth mindset. That's what you need. If you want your mind to grow, you have to struggle. Right, through each failure, you're getting stronger. All right. Because if you just quit, like you don't get it and you quit, guess what? That's a fixed mindset. You're not going to improve anywhere. You're going to be stuck at that problem. That's it, right? Because you want to avoid the pain, right? But you know that saying, no pain, no gain? Well, it's true with learning as well. If you don't experience any pain while you're trying to learn something, you're not going to grow as much. All right? So let's just jump right into this one. So here we have the square of a number added to the sum of the number, and 5 is a prime number. Okay, what the heck are they talking about here? The square of a number added to, so the square of a number, so some number, this is what I'm thinking about, some number squared, the square of a number added to the sum of the number, and 5. So we're taking this, adding it, adding to the sum of, so the sum of means I'm looking at two more things. So x squared, right, the square of a number added to the sum of, so I have certain things, a couple things here, the sum of the number and 5. What? The square of a number added to the sum of the number and 5. The square of the number added to the sum of the number and 5 is a prime number. Now, I think I'm a little confused what the heck they're talking about here. The square of a number added to the sum of the number. Is it x? The square of a number added to the sum of the number and 5. So I believe I think this is right. Right, we have some number, and this is the square of that number. Right, so the square of a number, so x is my number. Right, whatever number they're talking about, x is my number. Let x be my number. The square of a number, so here's my number, the square of the number, which is x, is added to the sum of the number and 5. And that should give me a prime number. So I believe this setup here is correct. The square of a number added to the sum of the number and 5 is a prime number. And a prime number can only be divisible by 1. So a prime number is a number divisible by 1 or itself. So like for example, 7 is prime. 7 is prime. So 7 is prime because I can only divide it by 1 or 7. There's no other factors that go into 7. And I know like 6 is not prime because it's divisible by 1, 2, 3, and 6. So I'm looking for a number that is a prime. So I want to prove this false. That was the goal, or they said prove it false. If they're telling me to prove it false, I know that it is false because they want me to show it to be false. So they're not going to make me waste my time by asking me to prove it false. Right, if it is true. Alright, so that means I have to find a number that will contradict this. So I want the answer to be a number like 6, something that's not prime. That's how I'll get my counter example. Let's just try a number out. I have some number. Let me pick 1 squared. Right. I'll make 1 my number. So I have 1 squared plus 1 plus 5. What does that equal? Well, I get 1 plus 6 equals, that gives me 7. Yep, there you go. It works. Torres got lucky again. He got first try. And simply just guess and check. I was just guessing to see, just to get started, what would happen. So I got 1 squared plus 1 plus 5 is, so I got 7 there. 7 is prime. Wait, no. It's a prime number. So they're saying it is prime. I gotta show it's not prime. So scratch that. I definitely did not get lucky. Alright. So let me go try a different number. Actually, so 1, let me just do a little side list somewhere. Let me put 1, right? That didn't work, so let me try a different number. Let's try, so 1 was odd. Let me try an even number. So 2 squared plus 2 plus 5. So I'm trying guess and check again. 4 plus 7, that's 11. Huh, that's also prime. Okay, so 2 did not work. Let me try a different number. So the square of some number. Well, let me try 3. If 3 doesn't work, we get 3 plus 5. We get 9 plus 8. Hey, 17. So 3 doesn't work. Alright. I could try 0. 0 is a number. 0. Well, I can already see 0 squared plus, alright, 0 plus 5. That's just going to be 5. So 0 did not work either, because 5 is also prime. How about, they didn't say I can't use a negative. So if you try positives, I tried 0. Let me try a negative number. Negative 1 squared plus negative 1 plus 5. So I get 1 plus 4, you get 5. Okay, still didn't get this. Alright, negative 1 did not work either. Alright, I tried the negative. How about, let me try negative 2. Negative 2 squared plus negative 2 plus 5. So I get 4 and 3. Still no luck. Negative 2 did not work because, wait, I'm trying to think, is this conjecture false? Let's see, what else can I try? I tried 0, 1, 2, 3. Let me try 5. 5 squared plus 5 plus 5. So I get 25 plus, wait, 5 squared plus 5 plus 5. 25 plus 10. 25 plus 10 is 35. Yep, there we go. So 5 is the counter example. So I can see, right, I got 35, right? So let me double check to see everything is good. The square of a number plus, or the square of a number added to the sum of that a number of the number that we picked, right, and 5 is prime. So I said 5 is a number I can try. When x is 5, I get 5 squared plus the quantity 5 plus 5. 5 plus 5 is 10, 5 squared is 25, and 25 and 10 is 35, and 35 is not prime. How do I know it's not prime? Because 35 can be divided by It's divisible by 1, 5, 7, and 35, right? And to be prime, has to be divisible by 1 or itself. So there you go. Took me a little bit of time, but I didn't give up, right? That's the key part. Don't give up and try to, look for patterns. When I paused for a second there, I was thinking about the number 5, and I was like, well, if I put 5 for x and I add 5, I know my number is going to end up with, either 0 or 5. So, right, because 5 squared was 25. 5 plus 5 is 10. So I kind of did that in my head. I was like, 5 might work, so I tried it and it worked after I did the workout. So 35 is not prime, and according to this conjecture, it says the square of a number added to the sum of the number and 5 will be prime. But that's not true because I found one case, therefore that proves this to be false.